morning all of you. We are discussing about the Faraday's laws. First law we are discussing Faraday's first law. Already yesterday I explained the statement. Just we will see what is the Faraday's first law. Amount of metal, yes, no, amount of metal which is deposited or dissolved at any electrode is directly proportional to sending charge to it. Sending charge to electrolytic solution. Generally, we are representing amount of the metal which may deposited or dissolved is denoted by W. The charge is denoted by Q. We written already W is directly proportional to Q. But in electricity we know charge Q is equals to IT. Right off that point, IT, because Q is equals to IT. But I want to remove the proportionality, then W is equals to ZIT. So what is the meaning of Z? Z means is nothing but electrochemical equivalent. Electrochemical equivalent. Shortcutly we are writing as ECE. So what is the things we have to discuss here? So whenever this electrochemical equivalent will becomes W, Z is defined as amount of metal which is deposited or dissolved at any electrode when IT should be 1. Means IT should be 1 means is nothing but we have to send current I is equals to 1 amperes and we have to send time, how much time? 1 second time. Or we have to send 1 coulomb charge. Means Q is equals to 1. Means it is nothing but we have to send 1 coulomb charge. We have to send 1 coulomb charge. We have to send. Then the amount of the metal which is deposited or dissolved at any electrode is nothing but electrochemical equivalent. This is the definition is helpful so many times for solving problems. When we are sending 1 coulomb charge or 1 ampere current 1 second time, then the amount of the metal which is deposited or dissolved in any electrode is only calling as electrochemical equivalent. All of you clear? So always charge is represented by Q should be expressed in coulombs, and current nothing but I is nothing but current should be taken in amperes, and T means time always should be taken in seconds. These are the fixed things. Okay, now how to explain one more law is nothing but Faraday's second law. These laws is only for both point of view. Based on this law, I will tell some important statements. Based on that, we are solving so many competitive ways. Faraday's second law. Yes, what is this Faraday's second law? First we will see the experiment, later we can design the statement. First of all, I am taking two different electrolytic solutions. I am taking them. In one container or vessel, I am taking zinc sulfate solution. I am taking one more vessel. I am taking, in that I am taking some other electrolytic solution. I am taking is nothing but copper sulfate solution. I am taking. Into this I am introducing some inert electrodes. I am introducing like this. Okay now? But both are connected in the series combination. Means what is the meaning of that one? Through both the devices or both the vessels you are sending same current. Nothing but same charge you are sending. Nothing but it is positive terminal and it is nothing but negative terminal. Yes. Whenever you take two different electrolytic solution, both of them connected in the series combination to the battery, means through both the solution you are sending same charge. Then my question, the amount of the zinc, is it equal with the amount of the copper? You are taking different electrolyte, okay, but through them you are sending same charge. Even though you are sending same charge, whether getting amount of the zinc is it equal with the amount of the copper in that second vessel? Should not. Why? The zinc is totally different from the copper. That's why different types of or different quantities of the chemical reaction will be happening. Then different quantities of the products will be forming. But you see here very carefully, weight of zinc metal metal is directly proportional to equivalent weight of zinc. Weight of the zinc is denoted by W of zinc and equivalent weight is denoted by E of zinc. There is no relation between two chemicals, but we have within the same cell we have relation between weight of the zinc and equivalent weight of the zinc. Same like we can write here, weight of the copper and is directly proportional to equivalent weight of the copper. So can you write here weight of the zinc by equivalent weight of zinc is equal to some constant? And we can take here weight of the copper by equivalent weight of the copper is equals to constant. A is equals to C, B is equals to C, then we can write A equals to B. That's why weight of copper by equivalent weight of copper is equals to weight of zinc by equivalent weight of the zinc. What is the statement of Faraday's second law? When we are sending same charge through different electrolytic solutions, then weight of the metal which is deposited or dissolved in any electrode is directly proportional to equivalent weight of the metal. How much combination or how many combinations you can take like that, W1 by E1, W2 by E2, W3 by E3, W4 by E4, like that is going on. So finally once again statement. So under according to Faraday's second law, same charge we are sending through different electrolytic solution, then weight of the metal which is deposited or dissolved at any electrode is directly proportional to its equivalent weight of the metal. Okay, now I want to tell something regarding equivalent weight of the metal. How can you get this one? Metal is nothing but element. What is the formula for equivalent weight? Atomic weight of metal by its valency. Valency are nothing but charge on it indirectly. Okay, for example, I want to find out the equivalent weight of magnesium. What I should do now? Atomic weight of the magnesium is 24. Its valency 2 because secondary group element. No, salt Mg plus 2. The charge only can be taken as 2. It is nothing but 12 grams. I want to find out the equivalent weight of zinc. What I should do? Atomic weight of zinc is 65. Copper is 63.5. Zinc is 65. By its valency 2. Otherwise it's becoming like Zn plus 2. No, so we can take like 2, then we are getting 32.5 like that. Are you clear? Yes, these are okay, but now I am explaining some shortcut methods based on this whole concept for especially competitive point of view. You have to observe very carefully. See, in electrolysis, we are sending a 1 Faraday charge. 1 Faraday charge through electrolytic solution. What is the meaning of 1 Faraday? 1F means water. 1 Faraday charge you are sending. What is the meaning of 1 Faraday? We don't know. Nernst equation. 1 Faraday means is nothing but 96,500 coulombs. Indirectly, this is the charge of how many electrons? This is the charge of how many electrons? 1 mole of electron. 1 mole of electron means is nothing but how many electrons? Yes, 1 mole of electron means 6.023 into 10 to the power of 23 electron. Whenever you are sending 1 Faraday charge or 96,000 coulomb charge, these all are equal. Or otherwise 1 mole of electron, we are getting an equivalent weight of metal may undergoing deposition or dissolving. What is the equivalent weight of the metal? Atomic weight of metal by its valency or charge. Right? Valency or nothing but charge. Yes, you have this statement. We can play with this electrochemistry related problems. What is the statement? In electrolysis, through electrolytic solution, you are sending 1 Faraday current. 1 Faraday current is nothing but 96,500 coulombs. Indirectly, it is the charge of 1 mole of electron. Nothing but Avogadro number of electrons you are sending. Definitely, what happening? Equivalent weight of the metal may undergoing deposition or dissolving. So, equivalent weight means what? Atomic weight of the metal by its valence. Just observe. I will ask you one question. First question I am telling you. Okay, you have NaCl solution you have. Through that NaCl solution, you are sending 1 Faraday current. How much amount of sodium may undergo in deposition? That's the question. Okay, yes, sir. Right on. 1 Faraday. By sending 1 Faraday through any solution, how much will be depositing? Equivalent weight of the metal is depositing. Yes or no? Sorry. Equivalent weight of the metal is nothing but Na. What is the equivalent weight of the Na? Atomic weight by valency. Atomic weight of sodium 23. By valency of sodium 1. So we are getting how much? 23 grams of sodium is undergoing deposition. Sorry. Sodium no. Sodium is undergoing deposition. Okay, just I will give you one more question. You have MgCl2 solution we have. Through that MgCl2 solution, I am sending 1 Faraday current. How much magnesium is undergoing deposition? Means undergoing reduction. Anybody? By sending 1 Faraday, we are getting a equivalent weight of magnesium is undergoing deposition. Equivalent weight of the magnesium means 24 by 2, nothing but 12 grams of magnesium is undergoing deposition as in the form of solid. Now my question, I want 1 mole of magnesium I want from the solution. Then I have to send how many Faradays? Yes. Did you got it my point? So by sending 1 Faraday we are getting 12 grams. But I want 1 mole I want. 1 mole of magnesium is how much one? Yes, very good. 24 grams of magnesium I want. Why? Because atom atomic weight in grams is nothing but 1 mole material. So if you want 12 grams, you are taking 1 Faraday. But I want 24 grams, then I have to send how many Faradays? 2 Faradays. Now I want to tell one thing. Okay, in any electrolysis, if you want to 1 mole of metal atom, you have to send how many Faradays current or charge in the form of formula?
It's balancing.
Yes, very good. Means in electrolysis, yes, 2F means what amount? Charge into Faraday. Yes or no? The charge only nothing but N or valence into Faraday. Means in electrolysis, for getting 1 mole of metal, we have to send how much charge? N into Faraday charge we have to send. What is N here? N is nothing but valency. Valency or nothing but charge on the metal. Okay, just you see one more question. You have AlCl3 solution. AlCl3 solution. Through this, I am sending 1 Faraday current. I am sending. How much aluminum may undergoing deposition? Just 1 Faraday. 1 Faraday means fixed. What is that one? Equivalent weight of the metal. Equivalent weight of the aluminum. Atomic weight, atomic number 13. 13 odd means double plus 1 means 27. Atomic weight is 27, but equivalent weight. By sending 1 Faraday, we are getting 27 by 3. Valency 3. There it is nothing but 9 grams of aluminum we are getting. But I want 1 mole of aluminum. 1 mole of aluminum is indirectly we want 27 grams of aluminum we want. Yes, whenever you want 27, what I should do? Valence into Faraday. Valence how much? 3. 3 Faradays you have to send to get 1 mole. If you want, just if you are sending 1 Faraday, just equivalent weight. You got clarity? So you have to fix in your mind, when we are sending 1 Faraday current through any type of electrolytic solution or 96,500 coulomb charge or 1 mole of electron, then we are getting always equivalent weight of the metal undergoing deposition or otherwise dissolving. Yes. Still, we have some other important formulas I will explain to you. See, at STP condition, very carefully you have to observe. At STP conditions, you are doing electrolysis. Okay, now you are sending 1 Faraday through which one? Water. Then, how much volume of hydrogen will be liberating? Or otherwise, how many liters of oxygen will be liberating at which conditions? STP condition. You taken water in a pot and you are introducing electrodes into that one, but you are maintaining 0 degrees Celsius temperature and 1 atmospheric pressure you are maintaining. Then compulsory from water, hydrogen gas and oxygen gas will be liberating. How much will be liberating is asking by sending 1 Faraday. Okay, just I want to tell explanation for this one. You see carefully. By sending 1 Faraday charge through any electrolytic solution, how much elements we are getting? Equivalent weight of hydrogen we are getting. Yes or no? What is the equivalent weight of hydrogen? Atomic weight by valence. Atomic weight of hydrogen will be 1. By its valency 1. Nothing but we are getting how much? 1 gram of hydrogen we are getting. By sending 1 Faraday current through water, we are getting how much? 1 gram of hydrogen we are getting. What is the volume of 1 gram of hydrogen at STP condition? Yes. Now at STP, generally if you take 1 mole of hydrogen occupies how much amount? Yes, very good. 22.4 liters of volume. But we are getting here just 1 mole means how much? 2 grams of hydrogen. Why? Because molecular weight in grams is calling as a 1 mole material. By getting 2 grams means 22.4 liters volume is there. But in this we are getting only 1 gram of hydrogen, nothing but how many liters? So by sending 1 Faraday current through any H plus ion having solution at STP condition, we are getting how many liters of hydrogen? 11.2 liters. No need to do all these things. Just for understanding, I am giving explanation for you. Just you are sending same 1 Faraday current to water or oxygen having material. Definitely oxygen gas will be liberated. How much at STP I am asking. Okay, by sending 1 Faraday, we are getting how much oxygen amount? Equivalent weight of the oxygen. Equivalent weight of oxygen means element. Element means atomic weight by valency. Atomic weight of oxygen 16. Very good. By its valency, oxygen can form how many bonds? 2 bonds. So it's nothing but 8 grams of oxygen we are getting. Yes. Whatever how much solution you can take, you are sending only 1 Faraday. Definitely we are getting only 8 grams of oxygen. But I want in values. What I should do? At STP, 1 mole of oxygen. 1 mole of oxygen means how much volume? 22.4 liters. But here, by sending 1 Faraday, we are getting 1 mole means how much amount? 32 grams of oxygen occupies 22.4 liters. But here we are getting just 8 grams. 8 grams of oxygen means how much? By 4. By 4 means is nothing but 5.6 liters. Means through any electrolytic solution which is containing oxygen atom can liberate oxygen. Okay, how much oxygen we are getting? 5.6 liters by sending 1 Faraday at STP condition. This is not helpful to you, but for understanding how it's kept, definitely is required. All of you clear? So, for any electrolytic solution, you are sending 1 Faraday current at STP condition, we are getting 11.2 liters of hydrogen gas and 5.6 liters of the oxygen gas. Commonly asking one more question from this. That relation radon is very helpful to solve so many bits. Come to this point. I have to work out one more statement here. By sending a 1 Faraday current through electrolyte which is having chloride ions at STP condition, how much chlorine gas will be liberating? These three chemicals only is asking in the competitive point of view. You have the one electrolytic solution, there chloride ions is there, and we are doing at STP condition, we are sending 1 Faraday current, then how many liters of chlorine gas will be liberating? Just you see, by sending 1 Faraday through any electrolytic solution, we are getting how much? Equivalent weight of chlorine we are getting. Yes or no? Yes or no? Yes. Chlorine means equivalent weight of the chlorine means Cl2. What is the meaning of this one? What is the meaning of equivalent weight of the chlorine? Chlorine is how much? 71. Yes, 71 means its valency will be 1. Nothing but 71 grams of chlorine we are getting. Sorry. 35 grams, no, 35.5 grams. Why? Because atomic weight by its valency, just the element, no. So equivalent weight of chlorine means atomic weight of chlorine by its valency will becomes 35.5 grams of chlorine. But I want that one in volumes at STP condition. So write down here at STP condition 1 mole of Cl2. 1 mole of Cl2 occupies 22.4 liters. But 1 mole of Cl2 means how much? 71 grams. Very good. 71 grams of chlorine at STP occupies 22.4 liters. But by sending 1 Faraday through any electrolytic solution which is having chloride ion gives 35.5 grams of chlorine. Nothing but how much? 11.2 liters. H2Cl2 same quantity 11.2 11.2, but oxygen gas will be 5.6 liters we are getting. These are important bits to solve so many competitive bits. Is all of you understood or no? Yes. By sending 1 Faraday current through any acidic solution, we are getting 11.2 liters of hydrogen gas at STP condition. So we are getting 5.6 liters of oxygen gas and 11.2 liters of Cl2 gas we are getting. So from this, I want to take some important problems. Once try to solve. First question. In the last two previous one class, one student asked me this. Don't you see how many coulombs of charge is required? How much charge is required? How much charge requires in coulombs for the reduction of 1 mole of Cr2O7 2 minus into Cr plus 3 ions. Good question. Dichromate ions we are undergoing reduction like Cr plus 3. Then how much charge is required is asked. You ask no doubt this one. Same concept have to see. What is this one? First, once you check it, reactant side chromium oxidation number is how much? 2x minus 14 is equals to minus 2. Then we are getting x is equals to plus 6, no? Plus 6 or no? Yes. How many chromiums is there? 2 chromium. Each chromium plus 6. 2 chromiums means total positive charge on chromium will be plus 2. Okay, the 2 chromiums means they are producing 2 chromiums. Each chromium carries plus 3. 2 chromiums carries plus 6. Are you understanding? So oxidation number we have to calculate for whole molecule, not per atoms. Okay, now change in oxidation number will be how much? 6 is the change. Means plus 6 is undergoing neutralization. Plus 6 is undergoing neutralization means 6 electrons is required. 6 moles of electron is how much charge? 1 mole of electron, yes sir, 6 moles of electron is required. 1 mole of electron means how much charge? 1 Faraday. 1 Faraday means is nothing but 96,500 coulombs. 1 mole of electron means this much, but here consumption is 6 moles of electron. That's why we require 6 into 96,500 coulombs to simplify this one. Very good question. For whole molecule, how much change is coming in its oxidation number? So plus charge is becoming, plus 12 is becoming plus 6 means 6 moles of electron is consumption. 1 mole electron charge is 96,500 and 6 moles means how much charge? Into 6. Is it clear? Yes. Now you have second question, good question. Copper sulfate solution you have. Copper sulfate solution you have. Through that you are sending 0.5 amperes current you are sending. For 30 minutes you are sending. 30 minutes you are sending. And 0.2964 grams of copper is depositing. Then atomic weight of copper is how much? Without solution also we can tell 63.5 will come, but you have to prove it. You have copper sulfate solution, through that you are sending 0.5 amperes current, that to 30 minutes, then this much of copper is depositing, then atomic weight of copper is how much? Yes, once you work out, first what we can get from these two? This is I, this is time, but the time should be taken in minutes? No, should be taken in seconds. It is nothing but how much? 1800. 30 minutes means 1800 seconds. Okay, from I and T, what we can get? Charge. Q is equals to I I value is 0.5 into 1800. 1800 means is nothing but 900 coulombs. 1800 by 2, nothing but 900 coulombs. Yes. Now what is telling? By sending 900 coulomb charge through copper sulfate solution, you are getting how much copper? 0.2964 grams of copper you are getting. But he want how much copper he want? One atomic weight of the copper. Atomic weight of the copper means it is nothing but how much? Atomic weight has to be calculated. Okay. If you want to get atomic weight, you have to send how much charge? Charge into Faraday. What is the charge on copper here? Plus 2. Means you have to send 2 Faraday's current you have to send to get atomic weight nothing but 1 mole of copper. Yes or no? 2 Faraday's means how much? 2 into 96,500 coulombs. Then do it simplification. How much is coming?
1,83,000.
You know, see carefully. Okay, this is okay, but do it simplification. This much giving that much, but if you want 1 mole means compulsory, you have to send 2 Faradays. You will get around 63.5 grams you are getting, check it. Cross multiplication. Do it later. See the third question. How much charge is required to produce? How much charge is required to produce 1 mole of Al plus 3 to Al? One question. And one more question. 1 mole of, good question this is, 1 mole of MnO4 minus into Mn plus 2. Good competitive mixture. For this how much charge is required? For this how much charge is required? To convert 1 mole of Al plus 3 into Al, very simple. Charge changes from where to where? Plus 3 to 0. Plus 3 to 0 means we want 3 moles of electron. Yes or no? 1 mole of electron. Generally for this requirement is 3 moles of electron is required. But we know very well 1 mole of electron means how much charge? 96,500 coulombs. But the requirement here 3 moles of electron, nothing but 3 into 96,500 coulombs. You do simplification. Next here, like a dichromatin conversion. What happened here? Mn oxidation number is becoming like plus 7. X minus 8 is equals to minus 1, then x is equals to plus 7. Manganese oxidation number is plus 7, but on product side plus 2. Change in electron. How many electron change? 5 moles of electron. Yes or no? 5 moles of electron. Yes or no? Then 1 mole of electron means how much? Yes, you know very well, 96,500 coulombs. But 5 moles of electron means 5 into 96,500 coulombs. I think 2019 or somewhere he asked similar model question in IIT means. How much charge or how many electrons is required? Is it clear? Can you see one more question? Understood all of you? Yes. Next question, good question. How much time we have to spend the current? Current I is equals to 3 amperes to silver nitrate solution, AgNO3 solution. To coat the metal surface, weight of silver is 0.42 grams. We know atomic weight of silver is also fancy number 108. Yes.